Hi, this is Michael Pfeiffer. This is another edition of the Metal Conversations podcast. In this episode, I'm going to introduce the product launch formula. This is going to be a series of discussions about different aspects of product development, launch, and post-launch that involve decisions and problems that require materials engineering help or considerations. Developing and launching a product can be stressful. There are many decisions, problems to overcome, and risks to mitigate. Risks are concerns about being able to meet performance requirements, being able to meet reliability requirements, that the product will work as needed, that it won't fail during use, and also that we can develop and manufacture the product and meet cost budgets. So we'd like the process of development and launch to go smoothly and be able to commonly meet deadlines, but this often is not the case because things we didn't consider pop up, or there are some surprises that we didn't think about, or things that we thought shouldn't be a problem become a problem. So many of the decisions and the problems and risks associated with development and launch are associated with the materials used in a product, because after all, any product is ultimately an assembly of materials that have been shaped and manipulated and modified to form components and the joints between components. So making an effort to engineer the materials, and I work on metals, so metals, for me to be metals specifically, but anyhow, we'll talk about all materials. Making an effort to engineer the materials will have an impact on product cost, performance, and reliability. And engineering the materials means thinking about things that affect how components perform, so thinking about the materials that are going to be used in components from the performance and reliability perspective, but also thinking about the materials used in components from a component fabrication perspective, and is the part being designed to make it easy to fabricate, because that will have a big impact on cost. Also thinking about materials from the perspective of joining different components together, because again, the materials in the different components will influence the ease of forming weld joints or solder joints or braze joints between components. So there are a number of different broad areas of product development and launch and post-launch that we'll be talking about today briefly, and then in future episodes I'll talk about them in more detail. So from the product development perspective, there's component design, supplier selection, product testing, and then fabrication and assembly process development. So for component design, materials engineering is important for helping to identify the materials that will be used in components. Now we have to think about, as I mentioned before, think about selecting materials that have the right properties to be able to meet the performance requirements, strength, or electrical conductivity, or appearance. We also have to think about the characteristics of the materials with respect to their reliability. How well will they stand up to corrosion conditions or fatigue or wear conditions? And we also have to think about ease of fabrication, perhaps sustainability, and also meeting certain requirements, industry standards with respect to performance, reliability. And then we also have to think about the availability of the materials. Will they be easy to get? So there are a lot of things that can be engineered in the materials used in a component to help to optimize performance, reliability, and cost. Then there's supplier selection. We have to make sure that suppliers are capable of consistently providing either materials or components or subassemblies that meet our requirements for the product, so they have the performance and reliability needed. And when we're evaluating suppliers, we can evaluate their materials, hopefully from something that's already in production from them, to identify whether these suppliers are capable. And we have to look at things more than just the properties of the material. It's important to look at the composition and the microstructure, and also the presence of any manufacturing defects, to really understand what the supplier's capability is. So just because they can provide a component that has the right shape and maybe even has the right hardness or tensile strength, that doesn't necessarily mean that product will be okay. They could have a problem with its composition, or a problem with its microstructure that could make it susceptible to fatigue or stress corrosion cracking, or it can have manufacturing defects that can make the component easy to fracture under certain conditions. So we want to make sure that we understand the supplier's capability and doing evaluation on something from the supplier that's already in production, also first article inspection, and evaluating parts as we get them that we're going to be doing any sort of product testing, making sure that the supplier has the capability that we need. Often people are thinking about using low-cost suppliers. They should be careful because all the engineering for a component or a set of components is not well understood. Then going with a low-cost supplier may be risky if they aren't able to provide the engineering support to help understand what's going to be required in the component and be able to help provide components that will consistently meet requirements. Then the next thing is product testing. Many products have to be tested prior to launching in order to make sure that products have the required reliability. This could be automotive components, aerospace, medical devices, and other applications where reliability and safety are important. When performing reliability testing, it's important to make sure that the materials that are in the components that are being tested match your specifications and are the materials that would be used in the final product. If the materials are different than what you expect them to be, then you may end up getting false passes or false failures, and that could result in making design decisions and other decisions that may be erroneous, may be wrong. So understand the materials that are being tested prior to doing the testing to make sure the materials are what you think they are, so that when you perform the tests, you get data that will be useful. And then finally, there's fabrication and assembly process development. During fabrication and assembly processes, we're taking materials and manipulating them to different shapes or joining them together. And we want to make sure that the processes are capable of, first of all, handling the materials and forming the components and joints as we want them to be formed into their desired shape. But we also have to verify that the properties and the microstructure and maybe in some cases the composition of the output also meets requirements. So we have to do various testing on the output of cross-section joints and make sure the joints have the right microstructure and the right shape. Look at components and make sure that they have the right microstructure and that there's no manufacturing defects that can lead to premature failures. Also, designing the processes, selecting the process, whether it's a fabrication or assembly process, and doing experimentation with the process parameters to dial in a process that's capable of manipulating the materials and providing output where the materials and the joints and the components have the right properties, have the right composition, have the right microstructure, so that the product performs as needed and has the necessary reliability, and also so that you have a production process that's capable of continually producing output that meets your requirements and has good quality. Once a product is launched, people then start focusing on fixing quality bugs with suppliers and production processes, because it's not always possible to work all the details out during product development. During this process, failure analysis of the problem items is needed to get the information about the materials in order to determine the root cause. So the information determined during the failure analysis includes the types and number of defects, material properties, and material composition and microstructure. And without this information, it's difficult to quickly determine the root cause of problems and fix them. After the launch is completed and after some time has passed and have a stabilized process, then it's time to do cost reduction and product improvement and trying to do things perhaps to increase product production throughput if you have a very successful product. One way to reduce cost is by using lower cost materials for components. Also, you can use lower cost suppliers, and finally, you can improve production quality. For looking for lower cost materials for components, sometimes during product development, it's better to design components using materials that we're really confident that they're going to be able to meet performance and reliability requirements, and we're going to be able to easily fabricate components out of them. But we know that they may not be the lowest cost materials, but we want to just have something that we know we have confidence in to meet deadlines for product launch. Once a product has been launched, then it might be time to revisit components and look for ways to reduce the cost of those components by using different materials or maybe making changes to the features of the component. maybe looking at ways to improve the manufacturability of the component. Then there's looking for lower cost suppliers. Sometimes organizations will try to use low cost suppliers, I'm using air quotes with that, right off the bat when they're trying to do a product development and launch. And to me, that's really risky. There's a lot of details that haven't been worked out, and low-cost suppliers sometimes come with the risk of really not having the technical expertise needed. And they may not be able to provide the input to help us design components or design subassemblies to help make sure that what we're doing makes sense. Because sometimes suppliers have input about our designs in terms of being able to make them do things, make changes to designs that improve manufacturability or improve ease of joining. And sometimes they can even make recommendations to tell us that a design really is problematic from a fabrication perspective. It's hard to expect that from low-cost suppliers, and since low-cost suppliers are often overseas, it can be difficult to communicate with them, and because of the language barrier and also because of time zone differences. So I recommend starting off with local suppliers within your countries, working out the details, and then maybe going to low-cost suppliers afterwards. In any case, once you start pursuing low-cost suppliers, you have to do the same things as with evaluating initial suppliers of components and materials. Make sure they have the capability of providing the materials that meet your requirements. That includes properties, composition, microstructure, and manufacturing defects. So that's it for this episode. Future podcasts will go into more details about the individual aspects of product development and production that I discussed today, and how materials can be engineered to improve the chances of making sound decisions that enable successful products and lower stress efforts from the people involved with making successful products. So that's it. Thanks for listening.